Hello, my Nerdy-Nawg-Dawgs. Thanks for tuning in. Today in class, we talked about using an area model to solve for multiplication. We should recall from last year that the formula for area is area equals the length times width. So in this case, we're just using a model to demonstrate that and what that math looks like. So if I were to model 19 times 4, I could say that my length was 19 and my width was 4. And then I would solve the problem like such. However, what we want to get used to doing as we move into multi-digit multiplication is to start to use compatible numbers. Okay, and this comes in really handy when we're doing mental math. So what I want you thinking about, and this is our tens trick that comes up again in chapter 3 when we review hundreds and thousands and multi-digit multiplication. This is to get us started though, is there's a tens trick. We can solve for just about anything times 10. And therefore it makes for really easy mental math. So in this case of 19, I know that in my tens column is a 1. That 1 represents 10. So I'm basically going to take this 10 away from the 19, and then I would have 10 times 4, because that is math I can do in my head without even thinking about it. You would not even need to write it down. I know that 10 times 4 is 40. So what's left over from that original 19 is 9 in your ones column. 9 times 4. We still have to solve for that. That's part of our original algorithm. 9 times 4 I know is 36. Again, math that you should be able to do in your head at this point. And then all you would do is add those together. 40 plus 30 is 70 plus 6 more, 76. So without thinking very hard or having to write much down, I should be able to solve for that. However, how does that work with our area model? If I were to do an area model to demonstrate how I just separated those things, I'm going to make my model just a little bit bigger. Need to get a little bit more on here. Again, the original length was 19, and the original width was 4. So I'm still doing the same problem. You should have just been able to do that math within your head, okay? However, we like to have you model it out because as things get more complicated, this might be something that really works for you. Okay, so in my head, I was able to identify that there was a 10 there, so I took the 10 out of the 19, and instead, all I'm gonna do is I'm breaking up this length. I chose to multiply by 10 instead of 19. So I'm going to say 10 is right about there, and I put my 10. However, I need to fill up the full length of the 19 because that was the original problem. So what's left over from 19? 9 more. Okay? 10 plus 9 equals my 19. This is not to be confused with, that's just a little measure there with the 9. Okay. So what I would also be doing then is I'm basically separating my original model into 2 separate models now. And then I could solve for it that way, just like I did the algorithm here. So from what remains, I've got a length of 10 and a width of 4 for this box here. So that would be 10 times 4, which we already said equals 40. That is the answer to this box. I'm going to color that in. Solved. I have now solved for that portion of the box. What remains is this length, which was the 9 out of the 19. And guess what? This width is the same on this side as it is on that side. So this becomes 9 times 4. And we already said that 9 times 4 is 36. So now I have solved for the entire box. Now here's the thing. Same multiplication as solving for this full model here. However, it's very likely you were able to do this math in your head. Whereas this math, you might have needed to write it down. So that's where this sort of modeling comes into play to help apply a visual to what it is we're doing, and to get us working on our mental math skills, which definitely come in handy when we have higher multi-digit numbers that we're working with. Okay, so let's do another one really quickly. If I had, say, how about 35 times, I'm going to make this easy math for us, 35 times 2. Okay, the first thing I would do is I want to work with tens. Tens are easier than doing this math in my head. And I just realized that is way too easy. You guys can probably do that problem in your head. So let's say this was an 8 here. Okay, so what we could do is then take out the tens. Let's take out the tens. How many tens does that 3 represent? Well, that 3 represents 30. So I could say 30 times 8. Okay, and then now I've used up that 3. It's no longer part of the equation. 30 times 8. I had to think about that one. And then the second part is you still have to complete what was in the ones column. 5 times 8. Okay, so all that means is on our model, we're going to represent the length. The full length was 35. So what I did in my tens was 30. What was left over was 5. And then guess what? Each time the multiplier stays the same and in an area model that is represented by the width. So the width was 8. Okay, so then I would just section off my square. What is my length of this rectangle? 30 times 8. I said square. Did you guys catch me? It's not a square. Rectangle. And then this one, the length is 5 times 8. And then you add those together. Should be able to do that mentally without really thinking too hard because we had easy numbers. Okay, I hope that area model is making a little more sense. Good luck, Nerdy-Nawg-Dawgs, and I will see you again for area model in Chapter 3.